Hello student, myself Millie Sankla, and in structure analysis part 1 we solve again the example of thin cylinder. Okay, now our first example of thin cylinder we already completed. Now our next example. Before solving this example, again read the data properly and then the values that we find out, solve it. Okay, cylindrical cell has a 3.5 meter length, 1.2 meter diameter and 10 mm thickness. The cell is subjected to internal pressure 2 Newton per mm square. Calculate the maximum shear stress and change in dimension. Okay, here the new one is, that is maximum shear stress. Okay, now first of all, as follow the rule, write down the data. In first, L is given. L is equal to 3.5 meter. Okay, here meter is given, so convert into mm. 1 meter is equal to 1000 mm. Okay, now my length is equal to 3500 mm. Next is given diameter. Diameter is also given in meter. 1.2 meter. Convert 1.2 into 1000 is equal to 1200 mm. Okay, now T is given. T is equal to 10 mm and internal pressure P is given 2 Newton per mm square. Now one by one find out. First we find out hoof stress. So right here, first is equal to hoof stress. Okay, notation of this hoof stress is equal to sigma C. So right here, sigma C is equal to PD by 2T. Write down. P is given 2. Diameter D we convert into mm, 1200 mm. Then 2 and thickness is given 10. And my answer of this sigma C is equal to 120 Newton per mm square. Okay. Now we second find out longitudinal stress. Again make a heading here. Second, longitudinal stress. Okay, longitudinal stress. And equation of this longitudinal stress, sigma L is equal to PD by 40. Now again write down the data. P, then 1200 divide by 4 into thickness T is given 10 mm and my answer is equal to 60 Newton per mm square. Okay, now we find out tau max. If you remember the equation of tau max is equal to our maximum shear stress, and that is sigma C minus sigma L by 2. Okay, write down. Sigma C we find out 120, sigma L is equal to 60 by 2. That means tau max, okay, that means tau max is equal to 60 by 2 is equal to 30 Newton per mm square. Okay, here we find out hoof stress, longitudinal stress and maximum shear stress. Now third, in this data also ask find out change in dimension. Okay, before finding change in dimension we find out strain. So here again make a heading. First heading is our hoof strain. Okay, right here first strain is equal to hoof strain and this hoof strain is equal to epsilon 1. Right here epsilon 1 is equal to sigma C by E minus 1 by m into sigma L by E. Okay guys, in this example Young's modulus and Poisson's ratio is not given. So simply write here, if in data these two values are not given, then assume. Okay, assume Young's modulus E is equal to 2 into 10 raised to 5 Newton per mm square and mu or 1 by m is equal to 0.3. Okay, now one by one put the values in this equation. Sigma C we find out 120 by 2 into 10 raised to 5 minus 0.3 and sigma L is equal to 60 by 2 into 10 raised to 5, and my answer of this epsilon 1 is equal to 5.1 10 raised to minus 4. Again, strain is unitless quantity, so here we can't write a unit. This is our unitless quantity. Now what is hoof strain? Hoof strain is nothing but that is the ratio of change in diameter to original diameter. Now find out change in diameter. Change in diameter del D is equal to epsilon 1 into D. Now just we find the value of epsilon 1, 5.1 10 raised to minus 4, and diameter D is equal to 1200 mm. Now my first change in diameter for this given thin cylinder del D is equal to, first change in diameter del D is equal to 0.612 mm. Okay, here we first find out change in diameter, that is del D. Now second we find out longitudinal strain right here. Second find out longitudinal stress. Okay, write down longitudinal stress, and notation longitudinal stress we already find out. Okay, and next we find strain. Okay, and equation of this strain is equal to epsilon 2. Epsilon 2 is equal to sigma L by E minus 1 by M and sigma C by E. Here stress is not, only strain written. Okay, now sigma L, value of sigma L is equal to 60 by 2 into 10 raised to 5 and 1 by M, that means mu is given 0.3, and this sigma C is equal to 120. Divide by Young's modulus 2 into 10 raised to 5, and my answer of this epsilon 2 is equal to 1.2 10 raised to minus 4. Now what is longitudinal strain? Longitudinal strain is equal to ratio of delta L by L. Now here we find out delta L, so cross multiply. Delta L is equal to epsilon 2 into length. What is the value of this epsilon 2 is equal to? We recently find out 1.2 10 raised to minus 4, and length of this thin cylinder is equal to 3500. Now finally delta L for this given thin cylinder is equal to 0.42 mm. Okay, this is our second change in length. Okay, now we third find out change in volume. Again write down the data. Okay, change in volume for thin cylinder is equal to, first write the equation, change in volume del V is equal to V and epsilon 2 plus 2 times epsilon 1. Now volume is equal to our area into length, then epsilon 2 plus 2 epsilon 1. Now what is area? Area is equal to pi by 4 d square into L, then epsilon 2 plus 2 epsilon 1. Now one by one put the value here. Pi by 4, d is equal to 1200 square and L is equal to 3500. Now our epsilon 2 is equal to 1.2 10 raised to minus 4 plus 2 into our epsilon 1 is equal to 5.1 10 raised to minus 4. Now my final answer of this change in volume is equal to, write down, 4512583 mm cube, that means 45,12,583. This is our final change in volume for given thin cylinder. Okay, now next example we find out the tensile stresses. Okay, in next example we find out the stresses is given and we find out unknown diameter. Okay, now our next example we solve. Okay, now we solve this example. Before solving this example, read the given data properly. Okay, in this example, efficiency is given. Read: cylindrical boiler to generate internal steam pressure P is equal to, write down the data also, P is equal to 2 Newton per mm square, and fabricated using T is equal to 12 mm. Okay, right here 12 mm. Now plate having limiting tensile stress. Okay, here tensile stress is given sigma is equal to 120 Newton per mm square. Okay, in this example only one tensile stress is given. That means this is a thin cylinder. If one tensile stress is given, that means here sigma C and sigma L both are equal. Okay, now if the efficiency of longitudinal and circumferential joint are 75% and 40%, here the efficiency of joint are given. First efficiency is longitudinal there. So write here notation eta L is equal to 75%, and second efficiency is given circumferential, that means eta C. Eta C is given 40%. Now this is given in percentage, so first of all convert into decimal. 75 divided by 100 is equal to 0.75, and here 40 divided by 100 is equal to 0.40. Okay, now find out safe diameter. In this example we find out safe diameter. Okay guys, if you remember in theory portion we covered the topic of efficiency of joint. Okay, now first of all the equation right here, hoop stress, write down hoop stress sigma C is equal to PD by 2T. If hoop stress is given, here we take eta L. Okay, now one by one put the value. Sigma C is given 120, then pressure P is given 2, diameter is unknown here, and thickness T is given 12, and eta L, value of this eta L is given 0.75. Now here we find out diameter D. D cross multiply simply 120 into 2 into 12 into 0.75 divide by this 2, and my answer of this diameter D is equal to 1080 mm. Okay, this is my first diameter because of hoop stress. Okay, this is first diameter. Now we find out second diameter. Okay, again this second diameter is due to our longitudinal stress. Okay, right here our second heading, longitudinal. Okay, our second heading is equal to longitudinal stress. Okay, and this longitudinal stress is equal to sigma L. Okay, notation of this longitudinal stress is equal to sigma L. Okay, now what is the equation of sigma L with respect to efficiency? Sigma L is equal to PD 4T. Here we write down eta C. Now one by one put the value. Sigma L is equal to 120, and pressure P is given 20, diameter D is equal to unknown here, then 4, and thickness T is given 12. Now what is the value of eta C? That is given in data 0.40. Now make a D as a subject. 120 into 4 into 12 into 0.40 divide by 20, and my diameter D is equal to 1152 mm. This is my second diameter is equal to 1052 mm. Now in this data ask, in this example ask find out safe diameter. So first of all write down the heading here, Now I explain you which one is taken from these two values of diameter. First is our lower value 1080 mm and second is our higher value 1152 mm. Now guys, in equation of stress is equal to PD by 2T or PD by 40. That means diameter is given in numerator. In thin cylinder and spherical vessel, our target is to reduce the stresses. Okay, so that if our diameter is lower one, then our values of stress are decreased. So safe diameter D is equal to 1080 mm. Okay, now D final answer is equal to 1080 mm. This is our safe diameter. Okay, here our example is complete. Okay, next example is our spherical vessel example. Okay, our example of efficiency just now complete. Okay, now we solve this example. In this example, first of all, the given data is a spherical cell. Okay, we solve the examples of thin cylinder. Just now this example is the spherical cell, so that our equation are changed here. Thin seamless spherical cell of D 1.5 meter diameter. Okay, again one by one write down the data here. Diameter D is given 1.5 meter. Then thickness T is given 8 mm and it is filled with liquid, so that internal pressure P is equal to 1.5 Newton per mm square. Find out increase in diameter, that means here we find out del D, and capacity of cell, that means del V, and our Young's modulus E is given 2 into 10⁵ megapascal and mu is given 0.3. Now what is megapascal? Megapascal is equal to Newton per mm square. Right here 2 into 10⁵ Newton per mm square. Okay, here our diameter is given in meter. Okay, so convert into mm. 1.5 1000. Diameter D is equal to 1500 mm. Okay, now this is the example of spherical cell. Okay, right here. Now our spherical cell equation are different from thin cylinder. What is we find out? First we find out del D. Right here, what is the equation of strain? Strain for spherical vessel is equal to del D by D is equal to PD by 4TE 1 minus 1 by m. This is the equation of strain. Here we find out value of this del D. So make a subject. Del D is equal to, cross multiply this term here, PD square, then 4TE 1 minus 1 by m. Simply again given value substitute here. P is given 1.5, diameter D we convert into mm, and 4 thickness T is given 8, and Young's modulus is equal to 2 into 10⁵ and 1 minus 0.3. Now my first answer, change in diameter for spherical vessel is equal to 0.369 mm. Okay, here we find out first value of this change in diameter. Now second value we find out, that is capacity of cell. That means here we take a change in volume. Okay, now write down here what is the equation of change in volume for spherical vessel. Right here, change in, write down, change in volume for spherical vessel del V is equal to pi PD raised to 4 8TE 1 minus 1 by m. Okay, now del V is equal to, here our value of P is equal to 1.5 and T is equal to 8. Okay, value of P, write down. Okay, here our value of P is equal to 1.5 and our value of T is equal to 8. Pi is equal to 1.5 and T is equal to 10 and diameter is equal to 1200 raised to 4 and Young's modulus is equal to 2 into 10 raised to 5, 1 minus 0.3. Now simply our answer of change in volume del V is equal to 1304650.66 mm cube. Okay, this is our final answer of change in volume for spherical vessel, that is 13,04,650. Here our example of spherical vessel to find out change in diameter and change in volume is complete. Now we solve our second example. Now we solve the last example of this spherical vessel. Okay, in this example, before solving we read the given data properly. Okay, in this example, thin sphere of 1.5 meter diameter, again write down here, D is equal to 1.5 meter, that means 1500 mm. Okay, and internal pressure P is given 3 Newton per mm square. Now find out or calculate thickness. Here thickness is unknown. Here we find out thickness for given spherical vessel, and this change in volume relation is given. Change in volume is equal to 2% of original volume. Okay, this relation is given. For that, first we find out our original volume. But okay guys, in this example again value of Young's modulus is not given, so simply make a heading here as a 2 into 10 raised to 5 Newton per mm square, and our mu, or we can say 1 by m, is equal to 0.3. Okay, now first we find out, write down here our original volume. Okay, first we find our original volume V is equal to pi by 6 d cube. Okay, now pi by 6 and d is given 1500 cube, and my volume is equal to 1.76 10 raised to 9 mm cube. This is the original volume of spherical vessel. Now we find our change in volume, because here in this example relation is given 2% of our original volume. 2% means percentage will be measured on 100. 2 divided by 100 and our volume is equal to 1.76 10 raised to 9, and my answer is equal to 35.34 10 raised to 6 mm raised to cube. Okay, now we find out thickness, because in this data find out the thickness. Now our equation of change in volume, write down our equation of change in volume for spherical vessel del V is equal to pi by PD raised to 4 pi PD raised to 4 8 TE 1 minus 1 by m. This is the equation of our spherical vessel for change in volume for spherical vessel. Now one by one put the values here. Del V is equal to 35.34 10 raised to 6 and pi. P is given in data 3. Diameter D is given 1500 raised to 4 and 8. Thickness T is unknown here, and value of this Young's modulus is equal to 2 into 10 raised to 5, then 1 minus 0.3. Okay, after solving we have to get, after simplifying this calculation, we have to get value of this thickness T is equal to point, write down, 0.569 mm. Okay, this is the thickness of our spherical vessel. Okay guys, here our chapter of thin cylinder is complete. Now next we start with our new chapter. Just now we stop here. Okay.